Okay, class, this is a review problem first, what we've been doing the last day or two. Find the roots, factor, find all the possible roots. We're actually going to skip that for the video because it's going to be a lot of them because it's all the factors of 112. So we're going to just sketch the graph. I'll sketch that over here by just looking at what it is on the calculator. So if we graph this, x to the fourth minus 7x cubed minus 12x squared. And hopefully you guys realize that there should be at most 4 zeros here. And graph it. Okay. So the gist of this graph, I know it's hard to see. If we do zoom fit maybe, we'll see if that'll help it a bit. Sometimes you have to just do zoom fit, and sometimes it works, but sometimes it doesn't. We'll see if it does here. So it touches there. Yeah, we don't see the rest in here then because of zoom fit. So anyway, what's happening is it's touching, it looks like, at 2, and then it goes through at 4 and then 7. If we make our Y window actually bigger, we'll be able to see it. So if I would make my Y min negative 200 and my Y max, like, I don't know, 200, we'll probably be able to see everything then. So let's see, there's that bounce. Yeah, that makes it a lot better. Okay, because it goes up and down in the Y. So that's what the graph looks like. Let's sketch it. So something like this. Okay, and then we find our zeros. Now, I know I talked about this in class, but the one on the left, if that's at -2 and it bounces, that should mean that it is a repeated one. That sure enough gives you 4, and then we can look at the table and make sure that the other one is 7. So let's go to 7 real fast. So, and actually -2 is also a 0. So 4 and 7 give you zeros. So here's what we do. We know that 4 and 7 are zeros, so right away I'm going to say for part C, x equals 4 and x equals 7, and I actually saw that x equals -2. So those are my answers already based on this graph. This again was 7, 0 and 4, 0 and -2, 0. Now on a test, if I have you give all the important information, you can say that this is 0, 1, 12 if you look at your table, and then you can find the min and the max using your calculators. I'm going to skip that for now because, again, the more important part is this. So for part B, we have to factor this. So let's say you didn't know how to factor this with this bounce, but you do know that these are both zeros here. We're going to factor out a 4 out of this piece. So I'm going to quickly do synthetic division. And you get a 0. Now I'm going to do it again with the 7. And sure enough, we got a 0 twice. So what happened was we factored this, and it turns into, we factored out a 4, which is that factor. We factored out a 7, which is that factor. And we're left with x squared plus 4x plus 4, which you guys should know is a perfect square trinomial. So it factors into x plus 2 and x plus 2, or x plus 2 quantities squared. So again, if you knew that's what that meant, you could have just written it and not done the synthetic division, but I was showing you that this means that it bounces because of that 2, and which means it happens twice. Now, you don't have to list it twice. Okay, it's just a squared 0. So that's our final answer for part B. Okay, that was the review. Now we're going to do, going backwards, we're going to come up with the actual equation. If I tell you, there will be no double roots here. And we're going to come up with a function. And again, a function means I want it as y equals or f of x equals. Okay, or f of x. So, the first one, I know that I have x equals 3, x equals -5, and x equals 2. The factors, when they're set equal to 0, so you set these equal to 0, and you get x minus 3 equals 0. So I'm going backwards. It's like I was solving. That's a factor, and x minus 2 equals 0. Okay? So now I have my three factors, and I'm going to write them as a function now. But remember, standard form means it's multiplied out. So first thing I'm going to do is put them here. But at this stage, you need to multiply them out. So I'm going to multiply these two first and FOIL it. And I get x squared minus 3 plus 5 is a plus 2x minus 15. And then I still have this x minus 2. So now I'm going to multiply it out some more. And I get f of x equals x cubed minus 2x squared. That's this one multiplied to those two. Plus 2x squared, because that's this times this. And then 2x times -2 is a -4x. Negative 15x. And then plus 30. So then your final answer, if you add your like terms, you get an x cubed. The x squareds cancel. You get a negative 19x and a plus 30. So this is the polynomial in standard form. If you graph this in your calculator, the lines of the graph should hit the x-axis at 3, -5, and 2. Okay, and that's a good way to check. Graph your answer and see if you get those as your solutions. Now that works when they're all nice real answers, but sometimes we don't have real nice answers. So sometimes we have imaginary answers. So we have x equals 2 and x equals 3i. Now you have to think backwards. How did we get to 3i? And some of you guys actually might want to do it this way, because there's plus or minus 3i, because it's a imaginary. So there's two ways to approach this. You can either work backwards. So this one becomes x minus 2. This one, think about how we get an I. We took the square root. So the reverse of taking the square root of something is squaring it. So you get x squared is equal to 3 times 3 is 9, but then I squared becomes a -1. Now if you set this equal to 0, x squared equals -9, we get x squared plus 9 is equal to 0. So this is the factor that gives you the plus or minus 3i. It gives you that 3i. And this is the factor that gives you the 2. So those are the two pieces we're going to multiply together. So when we FOIL that, you get x cubed minus 2x squared plus 9x minus 18, and that's it. Again, you can graph it to make sure that that one is there. You can only check the real answers, and then the imaginary you can synthetically divide and see. Excuse me. So, the last two are a little trickier because we have a plus sign. Now again, we can do what we did here. So, for ones with plus, solve for I, and square both sides. Okay? So for ones with the plus, solve for I and square both sides. So first of all, we know that x minus 3 or plus 3 equals 0 is our one factor from this. This one is x is equal to 2 plus I. Solve for I, so x minus 2 equals I, because at this stage it was squared. So now we're going to square both sides. And we get x squared minus 4x plus 4 is equal to -1. So to set it equal to 0, I get x squared minus 4x plus 5. So this piece right here, when you solve it, will give you this from the quadratic formula. So we got the quadratic that came from, and we can now do our problem. So now I'm going to just multiply this out. These go to these two. So, yep, and then negative 4x squared minus 12x plus 5x plus 15. So my final answer is f of x is equal to x cubed minus x squared minus 7x plus 15. Again, this will give you those answers if you solve it. First, you can look and get the negative 3 from your calculator, synthetically divide, use quadratic formula. You should get 2 plus I and 2 minus I. Remember, you get two answers with the imaginary. We're just giving you one of them. Now, if you're not comfortable with that, you can also, the other method is, you can do factored form if you just don't want to think about solving. And then remember, the imaginaries have two answers. So, factored form. This became x minus 6, or comes from x minus 6. This comes from x plus 3 minus I. No, that's not true. I don't know why I said plus. X minus 3 minus I. That's one of our zeros. And the other zero is x minus 3 plus I, the conjugate. Okay? So then we're going to simplify this and say we have x minus 6, x minus 3 plus I, and x minus 3 minus I. Now this is a little messier. It's a 3 by 3, so you're going to get 9 pieces. But when you do this, this will always simplify and make your nice answer if you don't remember how to do the method above, which was solving for the I and squaring it and reverse solving. This is just doing the factored form. So if I multiply this factored form out, I get x squared minus 3x minus xi for this to all three. Then I'm going to do this one, negative 3 to all three. So negative 3x plus 9 plus 3i. And then I'm going to do this back one to all three. Plus ix minus 3i and minus I squared. Okay, so first of all, if you did this right and have the right factors, the ix and the ix cancel. The minus and the plus. The minus 3i and the positive 3i cancel. So we're left with x squared minus 6x plus 9, and then minus I squared. Remember, I squared is negative 1, so minus negative 1 is plus 1. So that means my factor becomes x squared minus 6x plus 10. So that is the piece, and then we're going to multiply that by the x minus 6 to get our final answer. So over here, I'm now at x minus 6 and an x squared minus 6x plus 10. And if you did the reverse solve method from up above, you should still get this. Final step, multiply this out. We get f of x is equal to x cubed minus 6x squared minus 6x squared plus 36x plus 10x minus 60. Okay, so when you add your like terms, our final answer is x cubed minus 12x squared plus 46x minus 60. And that is how we get the polynomial from the zeros. Okay? All right, good. Then we are done.